This is Shram Academy. My little video tutorials that I'll make here and there when I can to help you guys along. So, these are practice examples that I sent home, and I want to walk through them with you. So the first thing we want to do is to go through our rules. Our main idea is to get the longest chain you can find. And I call that the Christmas tree. All the other parts I call the ornaments that we add to that tree, and the locations are governed by numbers, so that gets laid out. So our first step is to identify the longest chain, and don't be deceived by just writing from left to right. You got to look careful, and we'll see that in what I'm going to do as bypass that first example and do an easier one. Then we number the carbons, starting with the end closest to the branches. We want that lowest number possible. Okay, whatever that number, carbon number we have, that results in the lowest number possible. Okay, and we'll see some examples of that shortly. I'm going to circle each branch and identify their location. We're going to name them, right? And then we have to put them in a specific order, where we put the number, followed by a bracket, followed by the branch name and the parent chain. And what I want you to notice is that with the last branch, if we have more than one, there's no space between that and the parent chain name. Okay. Now, so we're going for the lowest number possible for our locations, but if we have more than one branch, we need to write them in alphabetical order. So, it's really important to know your ABCs. And then, of course, we have those cyclic alkanes, and if they're the parent chain, sometimes they can actually be an alkyl group, and I can go through some examples, right? But if they're the parent chain, then we're going to add the word cyclo to the prefix of the parent chain name. So I'm going to go ahead and jump to this one here. I'm going to zoom out a bit. I've made duplicates for the purposes of teaching this. Okay, so again, if we're going to go for lowest numbers, let's just play around here, and we'll go into that 12 o'clock position there. Hold up. We can call that 1, carbon 1, 2, 3, 4, 5, and 6. All right. So what does that give us? Well, that gives us, we obviously know it's a 6 carbon situation here. Now over here on the one on the right, I'm just going to grab a purple marker for that one. If we went counterclockwise and went 1, 2, 3, 4, 5, and then 6, that's going to give us a different set of numbers, and we can compare them side by side. What we definitely know, for sure, is that the parent chain, and I'm just going to call that PC for short, is cyclohexane. So that's going to be the name that this substance ends with. Now we got to take a look at our branches and name those guys. Well, we see them kicking off here. So that's a methyl there, and that's a methyl there. And again, I've made duplicates. Methyl here, and methyl there. So this is now going to be a dimethyl cyclohexane. But now we got to go to the numbers. So let's take a quick look at our parent chain. 1, 2, 3, 4, 5, and then 6. So this is going to give us what we're going to call 1, 3. So we got to go 1, 3, and there's got to be a comma between the numbers. Okay. Dimethyl, that means get 2 methyls out of the ornament box. Cyclooctane. Sorry, cyclohexane. My bad. It's late. Now, if we were numbering this one, and we followed this number format, this thing would end up being called 1,5-dimethyl cyclohexane. So, we see here that if we want the lowest number situation, we're going blue. All right, go blue. Not purple. Because that 5 there is obviously higher than this 3 here. So, I hope that makes sense. So, this is the incorrect name on the right side. This is the correct choice. Right? But there's lots of part marks up in here, right? So that's one error if we made that error. Okay, but got the rest right. You're going to get credit for that. And dimethyl just means we got 2 methyls. Now, what I've done is I've cloned this dude here because this one's funky, because what we might be tempted to do is just number the chain like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in that case, that would be a nonane. But I'm going to slap a question mark on that, because maybe I could, I don't know, start from way up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's also nonane. Let's slap a question mark on that one. Are there any other combinations that might reveal themselves? And I guess I started there at 1 because, you know, this one's, you know, pretty high up. So again, trial and error to find that parent chain. So is this a nonane? Well, let's play with some other spots here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a decane. Alright, so now we know that sequence. And I'm just going to use purple, just a different color to go the other way. What if we numbered it this way? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 2 possibilities here. So here's my parent chain. And it's a decane. And that's going to be the trick to watch out for, okay? Is to find that proper parent chain. Don't let the textbook fool you. When they draw a nice long chain, it looks like all the carbons are stacked together, left to right. That may not be the longest chain. Don't be fooled by a group that's high up, you know, up here. Okay? You got to look careful. All right, so is it the blue decane or the purple? Who's it going to be? Well, let's slap a question mark on that, because we can take our time to sort this out. Now we know that it's a decane, so now we want to actually identify the branches. Okay, and this is where your memory work of branches has to come into play. All right, so here we got a methyl group. Right, and therefore on this one over here too, we got a methyl group. So we know this Christmas tree is a decane of some sort. And this guy's just jumping out at me as ethyl. That pen's a bit thick there. Let me bring that back a bit. That's better. So we got an ethyl group there. And obviously the same thing over here. and I'm going super slow here, okay? You should be able to go a bit quicker than this, but I'm just taking my time. I want this to be, um, you know, locked in for you, okay? Maybe I'll use red. Yeah, sure. I can use red for this one. Okay, so this is 4 carbons. So we know that that's one of the butyls. But which one is it? Well, if we look at that, that's your second carbon in. So this is S-butyl. And again, memorizing those functional groups or those alkyl groups is vital to making this very efficient. So you don't have to keep looking back. Okay? Now, eventually you will remember it, but having those bits and pieces locked in your brain will make it so that, you know, when you're writing a test or a quiz and there's that pressure there, it's that muscle memory, that mental muscle memory. Okay? So again, this is also S-butyl. So what we want to key in on here, gang, is the carbons that they're on. So I'm going to zoom out a bit. We're going to go side by side and compare, and that'll help us decide what we've got. Okay, so I've got methyl here, methyl here. Now, do you have to like write it all out like I'm doing right now? No, not really, but I'm just doing this for teaching purposes, okay? Ethyl. Well, you know what we should do is probably put them in alphabetical order because that's one of the rules. So when we're listing our functional groups, let's do it that way, okay? So ethyl comes before methyl. Okay, and in this case, it would be a 3-ethyl. And on the left side case, it's going to be an 8-ethyl. Okay, so now we can go side by side and compare and see which combination gives us the lower of the two numbers. Methyl is going to, oh snap, I forgot. Butyl. How did I forget that? It's late. That's how. But what's great is a little bit of trial and error. We can catch those errors before it's too late, and we've got our finished product. So, S-butyl, because B comes before it. Now, you got to key in and realize that it's the B when we're talking alphabetics. Okay, this is not based on the S or the N or the T. Those guys don't play into the alphabet. Okay, B for butyl. All right. Now it's ethyl, then it's methyl. Okay. All right. Again, I'm taking my time with this, and it is late, so I'm a little bit sleepy, and that's all right. So there's your 3-ethyl there, and this then would be 6. Okay, and then an 8-methyl. Okay, so I got all my branches listed alphabetically, and now we can just look at our carbon numbers. Okay, so let's go blue. Alright, so this puts, in this arrangement, that's on 5, and ethyl's on 8. And this one is on 3. So, 3, and 3, and 8, and 8. And now we've got our discrepancy. We got a 6 there, and we got a 5 there. So, that means then that this is the correct order on the left side. So, this beast is going to be called 5 S-butyl, or if you wrote sec-butyl, that's cool too, dash 8 ethyl dash 3 methyl decane. Whew. All right, so we got our everything's alphabetical order. We got our lowest numbers possible. And that final branch merges right with the parent chain. Okay, so that's the correct answer for that one. And with a fully worked through solution. All right, so this is the correct choice here. This one, not so much, because of that 6. 5 is lower than 6. All right, now what's cool is if I jump over to these guys over here, we can practice building them or drawing them. Okay, so with this, you're going to kind of work backwards. We're going to start with that parent. So I got a heptane. That means 7 carbons in a row. So I'm just going to go 1, 2, 3, 4, 5, 6, 7. Okay, so I've got dimethyl on carbon 3. So that we're going to draw a methyl here. 4 and 5, a methyl there. And then carbon 4, we've got an ethyl. Now you can draw it either above or below. And you'll see when we build our model kits that it doesn't matter, because with single bonds, they can rotate around each other. Now we're going to actually fill in our hydrogens for the rest of the compound. Oh, and the instruction was to do the fully expanded ones. My bad. Hold up. I'll start fresh. 1, 2, 3, 4, 5, 6, 7. Here we go. All right, 3 is methyl. So methyl's fully expanded, structural, looks like this. And that was the instruction, was said structural. All right, which you'll see is a bit time consuming, but that's okay. All right, so that'll just help reinforce, you know, the basis for, you know, why it's 3 hydrogens here on this end and 2 in the branches, and then, well, obviously this one here only has 1 on carbon 3. Carbon 4, I'm going to draw my ethyl going like this, and then we'll have her come out here like that, like that. There's going to be an H on that one. Now it's getting crowded up in here, what we call steric hindrance, technically. So that's carbon number 5. And obviously then the rest are going to be saturated with your hydrogens. Now, that's your structural. Let's look at condensed. 1, 2, 3, 4, 5, 6, 7. Even though I didn't ask you to do this, it's good practice. Okay? And again, you can draw the methyls above or below. Doesn't matter. It's all just for kind of spacing things out. So here's condensed version. So we're going to need 1 hydrogen there. We're going to need 1 hydrogen there. There you go. So this is condensed, somewhat condensed. And if we wanted to super condense it, we could clump them together. Kind of like this example here, where you've got some super condensed, that bottom chain that they're using to psych you out. Right? So we got our dimethyls, we got our 2 methyls there on number 3 and 4, and then we got our ethyl on carbon 5, or 4 I should say. Okay, now I want to take this up another notch and draw this as the line diagram. Okay, so we're going to go 1, 2, 3, 4, 5, 6, and 7. So carbon 1, 2, 3, there's a methyl there. There's the ethyl there, and there's a methyl there. Spidery looking thing that it is. Okay. Now again, I didn't ask you to do the condensed, I asked for the structural. This is full structural. Where we're showing all the atoms and all the bonds. Condensed structural and then line diagram. And I'm just throwing these in for extra practice. Okay, propyl cyclobutane. All right, let's check this out. Cyclobutane. 1 ethyl, 2 propyl cyclobutane. Okay, so cyclobutane, that's going to be 4 carbons connected together. 1, 2, we'll make that into a nice neat little square. 3, 4, like that. Now, we can pick any one to be carbon number 1, it doesn't matter. I'll just go up here to the top left, just cause. Alright, so that's number 1, which is going to be an ethyl group. So we're going to have an H there. This is getting crowded. Let me move this down a bit. Do you have to draw it as a square? Sure, why not? We can use the lines of the page. That makes life nice and neat, easier. There you go. There, we're going to draw that ethyl group. Fully expanded. So 2 hydrogens want to go there. There's my ethyl. Okay. And on 2, propyl. Now, since it just says propyl, that means that it's N-propyl. So that means we got 3 carbons just in a straight line coming off like that. So 2 hydrogens there. And obviously the 3 on the end. Okay. This guy needs another hydrogen. So hopefully you see the value in actually drawing the full structure when you're just starting out. Okay, it just helps install and account for every atom in your brain. Okay, and just for funsies, I'm going to highlight that parent chain. You don't have to. It's not wrong if you do. It's not wrong if you don't. If you're looking for full structural, there we go. Okay. Now, again, let's condense the sucker. See what happens. Oh, I'm going to have to move over to the right a bit. Okay. How condensed can I get? Well, I can go CH, CH, CH2, CH2. CH2, CH3, we can even further condense that down there. Let's connect those guys there. There's your cyclo. And let's slap 3 carbons in a row with their adjoining hydrogens. Okay, now if I want to draw this as a line diagram, there it is there. 1, 2, 3, kicking off there. And we'll just draw the ethyl that way. Could we draw it the other way? Sure, why not? We can even draw it at an angle like that. That's cool too. Right, that would work. So there you go. And our final one. Ooh, decane. The sucker's going to be long. Here we go. I might write it a bit smaller. Or come up from the far end. I'm going to start down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's my parent chain. Oh shoot, we have ourselves an error, my friends. And there it is there. Let's get rid of that. Yep. And it's going to see a spelling. There you go. There's no dash. So that was a little boo-boo, which we fixed. And maybe we can have that. No, it's giving us suggestions. Step away. Okay. So let's check it out. We've got 2-methyl. So there's your methyl group. And you can actually draw the bonds longer if it's getting crowded. I'll show you what I mean. 2-methyl. Okay, so this is a little bit crowded in here, but that's okay for a full structural. Again, this is the first time you're doing this. You're kind of walking before you run. Okay, so carbon 3 is fine. It's just hydrogens there. Carbon 4, we got an isopropyl. Here we go. It's going to get a bit crowded. Since I've got a functional group or an alkyl group going above there, I'm going to bring this down. And as I said, you can actually just extend these bonds if it's getting crowded. So, isopropyl. Isopropyl. For isopropyl, I want to have my carbons on either side, sort of doing a flanking pattern to give that isoness, the sameness. That might be a little bit crowded there. Yeah, it's a bit crowded. Okay, so watch this. This is so cool. For these Lewis, it's cool if they're just literally straight lines, 90-degree everything. Okay, we don't have to have or convey that 3D shape. All right, this is going to give us some room. Let's write our expanded version. There you go. And there's going to be a CH3 group over here. It's time consuming in its way, but you know what? It slows you down. So the probability of catching minor errors as you go is higher. You can just catch them and fix them before your final answer. And it's just practice for getting to know these things. And the expanded form will allow you to see it. Okay, so there is 7-ethyl. Oh shoot. I forgot my 7. See, I was talking about catching these. 7. 1, 2, 3, 4, 5, 6, 7. Ah, there you are. 1, 2, 3, 4, 5, 6, 7. So you get tired. Now again, I want to, oops, wrong bond. I'm going to slap my carbon. 1 carbon up there. And hydrogens on either side of it. And then we can slap another carbon up here. So that can just be going up instead of to the right. And you'll see once we build model kits. Okay, now we got our ethyl. Okay, so let me just do a quick grocery list. I got ethyl on 7. I've got methyl on carbon 2. I've got my isopropyl on carbon 3. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got my decane. All right, so I'm all good. There it is there. Little grocery check. Did I get all the items? Yeah. Okay, so now what we can do is condense that beast. And again, I didn't ask you to do that, but again, just good practice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to move those over a bit because that's going to get busy with the CHs. And there's a couple other condensation options. This is kind of cool. We can look at CH3. CH with the CH3. And I could have drawn that below. That would have been legit. So carbon 2 is that methyl group. Carbon 3 is just a CH2 group. Carbon 4 is a CH with my isopropyl, which is going to be CH, and then sometimes you'll see it drawn like this. And it's good. It is good form to draw the C's to the C's like that. That's not bad. Okay. If you're going to connect it and draw a carbon first, make sure it goes C to the H3. Okay, don't connect the bond to the H. Right, so make sure that the H's are coming off the carbon. All right. Someone was asking about something like that. Just make sure that if you're going to do it that way, it looks like that. It's just better form, carbon to carbon like that. All right. So that's 4, 5, 6, 7. Now I'm going to pop up an ethyl over here. And just for the heck of it, I won't connect that. Okay. So 7, 8, 9, and 10. Woo! Look at that sucker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, all good. Checks and balances. Alright, now we can play with the line diagram. And again, I didn't ask you to do these, but I'm showing you them for just learning. 1, 2, 3, 4, 5, 6, 7, 8. Oh, this is getting sloppy. Let's tighten that up a bit. Maybe having thicker lines is a good idea. 1, yeah, that's easier. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeesh. Bring that down a bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Okay, cool. So carbon 2 is a methyl group, so I'm just going to go like that. Carbon 3, nothing. Carbon 4, we got an isopropyl. Five, 6, 7, we got an ethyl, and we can turn that like that, or it could go the other way too. That'd be allowed as well. That's fine. Let me just make sure that there's a distinct corner there, vertex. There. So that works. Okay. So that's all of them. There's your practice for these questions, and they're all there now for you to review along with this nice video. And that's me signing off. SRAM Academy 2023-24.